In this video, I will be going over some examples on how to convert signed decimal numbers to binary and vice versa, using the three representations of sine and magnitude, 1's complement, and 2's complement. So first we're going to convert several decimal numbers into signed 12-bit binary numbers. So first notice that we'll be using 12 bits, okay? So first we need to find 67 in binary. 64, 67, 64 plus 3. 1, 1, 0, 0, 0, 0, and a 1. That's a 64, but since we're using 12 bits, so 0 the first, which is the sign, and then we fill the rest with zeros. Okay, what about the 1's complement? When it's a positive, we don't do anything to it, remember? So we just copy as it is, basically. That's exactly how it is. What about 2's complement? Positive numbers, we don't do anything to it. 0, 0. Okay, so that's it. Positive numbers is the same in the three representations. What about negative 67? So we already have 67 in binary. If it's sign and magnitude, the first we put on 1 for a negative, and then we copy the rest. 1, 2, 3, 4, and then 1. Now, what about 1's complement? 1's complement, we start from positive. So we're going to start from this one. Okay, so starting from this one, or actually this one or this one, which is all the same, right? 67 positive. Starting from that one, we're going to complement each of the bits. Okay, so including the sign. So 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0. Okay, remember, this is a 1. We're complementing this one. Okay, not this one. Okay, we're going off this one on the top, or this one and this one, which is the same. Now for the 2's complement, remember there's two ways. We can, I'm gonna put a line here. So for the 2's complement, we can plus 1 to 1's complement. Okay, that's one way of doing it. Okay, so we just add 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1. We have the 1's complement here. That is, okay, let me erase this. So that's the 1's complement. And if we add plus 1, we get that one. So because 1, 0 plus 1 gives us that just a 1, and we don't carry it to the next side. Okay, so that's just one example. Let's do more. 348. So 348, first we need to what? Find the binary number. So I'm going to do 1, 2, 4, 8, 16, 32, 64, 128, 256, 5, 12. I think that's enough. So that's going to be that. And then if you grab your calculator and you do 348 minus 256, we have 92 left. 92 left, that's 64 minus 64. It's 28. So that's 16. And so we have 12 left. So 1, 1, 0, 0, put 0, put 0. Okay. So that's a 348 in binary. So for sign and magnitude, we just copy it. I think I'm going to copy it from right to left. 1, 1, 1, 0, 1, 0, 1. And then we put the sign, which is positive, and then we fill the rest with zeros. Remember that leftmost bit is the sign. In this case, since we have 12 bits, we have to fill with zeros the remaining empty spaces. Okay, 1's complement again. We don't do anything to it. Oops. no yellow. We don't do anything. We just copy straight. There's nothing to do about it. Same thing for the 2's complement. Okay. What about negative numbers? So it's a negative, and then we just copy exactly. It is 10, 10, 1, 1, 1, and then 0, 0. 1's complement. We have to invert starting from this one. Invert all of them. 1, 1, 1, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1. Okay, so now for the 2's complement plus 1, 2, 1's complement. Okay, we're gonna keep doing that example for one more time. Okay, so how do we add a 1 to this one? Remember 1 plus 1, that's a 2. We have 0 and we carry 1. Remember adding plus 1 here. You want to put imaginary line here. So 1 and 1, that's a 2. So we carry 1. 1 and 1, that's a 0 and a 1. So that's a 1, and then that's 0, 0, 1, 0, 1, 0, 1, 1, 1. Okay, so that's the final one. So we're adding 1 to the 2's. We're adding 1 to the 1's complement. Let's do another example. So you can already tell that these three all the same, right? Because they're positive numbers. But just keep doing it. So 1, 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, 10, 24. I don't think we need any more than that. So 5, 12. So I'm doing 681 minus 512 in my calculator. So that's a 169. 169, the 256 doesn't fit in there. 159, I can fit 128. So in the calculator, 169 minus 128. I have 41 remaining. So 64 doesn't fit in 41. 32 fits in 31. So I'm subtracting that from 41. So I have 9 left. 9 left, or you have this one and this one. Okay, so now I'm still gonna copy from right to left because I don't know how many extra spaces we have on the left. So 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and a 1, 1, 0. Okay, I think I'm missing a 0 here. So 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and a 0, 1. There you go. And then we put the sign, which is a positive, and then we fill the rest. In the case of the 1's complement is the same exactly for positive, and the same for 2's complement. So what about the negative 681? So sign and magnitude, we just change the first bit, which is the sign, and the rest we copy straight from the top. Okay, now just for fun, we're gonna do the 2's complement without having the 1's complement, okay? And because we're gonna practice the shortcut method when doing this. So the shortcut method tells you that you copy zeros and first 1. So starting from here, I'm gonna copy all the zeros starting from the right. Do I have any zeros? I don't have any zeros. And then I'm gonna copy the first one. Do I have a 1? Yeah, so I have this one right here. So I'm just gonna do a 1, and then I'm gonna invert the rest. So I'm gonna invert. I'm gonna have a 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, and then remember I'm inverting this. I'm going off of this. So this is a 1 also. Okay. So you can see that even we don't have the 1's complement, we can get to the 2's complement using the shortcut. Okay, let's do now the 1's complement. We just need to invert all of this. That's a 0 1 1 0 1 0 1 0 1 0 1 1. Remember, I'm inverting this one, not this one. Okay, let's do another example. 2020. The year of 2020. Okay, let's do 2020 in binary. So 1, 2, 4, 8. What about 2048? We're not even going to use it. It doesn't fit in there. So what fits in there? 1024. So 2020 minus 1024. So I have 996 left. So I can fit this guy from minus 512. I can fit the 256, so minus 256. I can fit these 128. I can fit 64. I can fit 32. And then I need a 4. I have 4 left. So you start with the 220 and you need to see if this one fits, then you subtract it. To the result that you get, you need to check if that one fits. If yes, you put a 1 and you keep subtracting things. Okay. So now that we have that one, so I'm just gonna copy it. So 0, 0, 1, 0, 0, 1, and then a bunch of ones. How many ones? These 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ooh, we barely had space for the sign, right? If we had a bigger number that require us to use the 2048, then we cannot use a 12-bit. We probably need a 13-bit or something else more. So now sign for the positive, we have a 0. And remember, all of these are the same for positive. For positive. Positive. 0, 1, 1, 1, 1, 1, 1, 0, 0, 1, 0, 0. So let's have 3, then another 3. Yeah, just double checking. Okay, perfect. So let's do now the sign and magnitude. So sign and magnitude, remember, that's a negative, and then we'll just keep. Okay, now we're gonna do again 2's complement first. So you copy zeros. So from the right to the left. Okay, so you're gonna copy. That seems like confusing. Okay, so from in this direction, right to left. Okay, so from the right to the left, right hand side to the left hand side. So you're going to copy the zeros and the first one, then you're going to invert. Okay, see the other video. Okay, see the video. So we're going to copy the zeros, all the zeros. So that's a 0 and a 0. And then we copy the first one. That's a 1. Okay, and then we complement this rest. Okay, we complement that one. So that's going to be a 1, 1, 0, 0, 0, bunch of zeros, zeros, and a 1. Okay, so we copy copy all the zeros from the right to the left. You copy the first one, and then you invert. That's for the 2's complement shortcut method. Okay, so what about the 1's complement? The 1's complement, we just need to invert this guy right here. So we're gonna do 1, bunch of zeros, and then 1, 1, 0, 1, 1. That's it.